In this demonstration, Dr. Mukherjee will titrate potassium permanganate against a solution of ferrous ammonium sulphate, also known as Mohr salt. First, she will do this without the addition of an acid to the Mohr salt solution.
Here is ferrous ammonium sulphate. Look at the green hue that it has. I am going to titrate. The formula is on the board. I will explain you later. It's a redox titration. So potassium permanganate, which comes in an amber color bottle, it's not a primary standard. So that is going to react with ferrous ammonium sulphate. I can get its concentration by doing known amount of ferrous ammonium sulphate and then titrating it to the end point. I can add a lot of water to the analyte, but nothing to the titrant because the concentration stays the same, right? Okay, so I'm going to titrate this with potassium permanganate, and let me dissolve this. It's little, you can see little specks, so let me completely dissolve this. Mind you, there is no indicator. You will see, you will discover why it is in that way. So I'm starting for the reaction to go. Just like every single titration, you will add, you will start, and then you will wait. You will add one more drop. You see the solution is not so transparent. Keep watching, I'm going to discuss that. Alright, one more drop. And then look, this is done. And the solution is not transparent. I want you to notice that. Okay? Alright, so one more drop. Okay. We added 2 drops, but that's okay. I hope you are noticing that the solution is getting really opaque. I don't need to add that much, but here is the end point. But look at the solution. It's just like a gel. It's not transparent. What happens is iron forms iron 3 plus, and iron 3 hydroxide, which it forms with water, is not soluble in water. So in order for doing this experiment, I should have the acidic environment. Then the oxidation reduction reaction will go without having a precipitate.
Now Dr. Mukherjee will perform the same titration, but first she will add sulfuric acid to the Mohr salt solution to prevent the formation of a precipitate.
This time I'm adding sulfuric acid, about 10 ml, acid to water. Here I have on my left hand the ferrous ammonium sulphate dissolved in water. I didn't want to waste time, just dissolved it ahead of time, but this is in acidic environment, and I will do the titration again. So you will see the difference. Okay, there is no indicator, remind you. Okay, let me show you what do I mean by, okay, look at the solution, it's transparent. So in the acidic environment, iron 3 hydroxide is soluble. And remind you again, there is no indicator. You will see the reason at the end very clearly. Okay, look, it is lasting longer time. Let me show you one more technique. In case it splashes on any other side of the beaker, you can add water I'm just showing it to you for two different reasons. You can add as much water as you want in your analyte. Titrant should be just the same concentration as you started with, because analyte depends on the mole and titrant depends on the molarity and the volume. Okay, it's very close. Let me not lose it. Alright, look at this, the end product. It's a clear solution, light passes through, and it is the end point signified by the color of potassium permanganate. The volume is currently 36.00 milliliter. I'm going to write it on the board, and then we will calculate when you guys come back to class.
Here are Dr. Mukherjee's measurements. The first pair shows the volume of potassium permanganate in the burette before and after the first titration without the sulfuric acid. The second pair shows the volume of potassium permanganate in the burette before and after the second titration with the inclusion of the sulfuric acid.